but it would be a shame to bring you on the show to not get your take of what exactly is insulin resistance. We've had it explained probably 100 times, and the thing I appreciate the most is how everybody just has a slight nuance and explains it just slightly different. So if this is a good point in the story, maybe we could have you in the most Ben Bikman way explain what is insulin resistance.
Yeah, in fact, if I'm going to speak with any authority, let it be what I'm about to say. So anyone whose definition of insulin resistance differs from mine is wrong. This is the one thing I will be a little bold with. So insulin resistance is a pathology with two parts. It's a coin with two sides. You cannot have one without the other. It does not work in all but the most acute setting. You know, if we're talking about really developing and progressing insulin resistance, it will always have these two parts. The first is the insulin resistance part itself, which is when the hormone insulin isn't signaling or isn't getting the response throughout the body that it used to. That is when the cells, some cells, not all, but some cells in some tissues have become insulin resistant. So that's the first part of insulin resistance. But then the second part is very relevant too, which is if we flip this coin over, it is that blood insulin levels are elevated. There is no insulin resistance without elevated blood insulin, a condition called hyperinsulinemia. There is actually one instance, which is true starvation, which is not the same as fasting, but that is so uncommon as to just not really need to be discussed. But in that case, it would be insulin resistance with low insulin, but the conventional insulin resistance, even the insulin resistance of puberty, the insulin resistance of pregnancy, which are states of physiological insulin resistance, it still meets those same two definitions. Now, of course, what I focus on mostly as a scientist and what we've been discussing is the pathological insulin resistance, or the form of this that's contributing to diseases. It is still both of those variables. Insulin isn't working the right way at all of the cells of the body, and two, blood insulin levels are elevated. But number two, that second point matters. It's so important when we remember or hear what I'm not saying, which is that some of the body's cells and some of the body's tissues are still responding to insulin perfectly well. They're as sensitive as they ever were. But now they're getting overstimulated because of the hyperinsulinemia. The elevated insulin is now doing too much at those cells that are hearing everything too well. And then, of course, it's still not working particularly well at the cells that have become insulin resistant. And we see this perfectly encapsulated, these two aspects of insulin resistance, in the two most common forms of infertility. In women, it's polycystic ovary syndrome, which is a disorder of the elevated insulin part of insulin resistance, where the high insulin is inhibiting her ovaries' ability to create estradiol. And so it ends up creating just a bunch of testosterone by default. But on the other hand, in men, the most common form of infertility is erectile dysfunction. And that's a consequence of the insulin resistance of the blood cells, of the blood vessel cells, rather, the endothelium, or the lining of the blood vessels, which are reliant on insulin in part to activate this process of vasodilation, or expanding the blood flow to enable, in this case, normal erectile function. So we see that, as I said, encapsulated very well within the two most common forms of infertility, the ultimate definition of insulin resistance being a pathology of two parts: one, the insulin resistance, and two, the hyperinsulinemia.
We will take that as the standard explanation
Yeah.
for insulin resistance. You heard it here first from
Yeah.
Dr. Ben Bikman. He may have lost some clout on our last episode by saying that frosted mini wheats were like the best cereal. That is objectively, scientifically not true, according to a study I just made up. But yeah, that was a great explanation. And so you alluded to, sexual function as an example, and fertility issues. But what are some of the other issues that people should just always be thinking of when they hear insulin resistance, next steps, associated diseases? You do such a good job with this in your book, but just as a flyby of some of the things that people should be pretty darn nervous about.
Yeah. Some of the lowest hanging fruit, which is to say the most obvious signs and symptoms of insulin resistance that people can look for, one is just blood pressure. If a person has ongoing hypertension day after day, regardless of how they sleep, because sleep is a huge contributor to high blood pressure. So if someone sleeps well and they're still hypertensive the next day, you really should assume you're insulin resistant or get that checked. Second is to look at the skin. The skin is a window to the metabolic soul, particularly around the neck. And so look at or feel the neck And if a person feels that they have kind of tissue papery crinkled neck, skin, the skin around their neck, and if they can see it, if it's darker pigmented, that's easier to see on fairer complected or lighter complected people. But that's a condition called acanthosis nigricans, where the melanin, it gets darker. Now, just as a point of interest, people will refer to some different ethnicities as melanated or not. As the fact of the matter is, every body has melanin. It's just different colors of melanin. So it's not like there are races or ethnicities with different amounts of melanin. That's not true. It's just different colors of melanin, just so that we're clear in how bigoted we want to be when we speak about different races. But anyway, so the melanin will just be a darker melanin. So it'll be a darker, but a tissue papery feeling skin around the neck. But at the same time, they may also have a second skin problem called skin tags, as a kind of colloquial word or term for it. But that's almost like little mushrooms of skin. It's not like a big lump, like a mole. It's rather like a little column of skin sticking up. And people know what I'm talking about. We've all seen them. Both of those are very much signs of insulin resistance, and they are very reversible as insulin sensitivity improves.
Interesting. Okay, going back to your talk, you show different situations of what might happen with, changing either energy coming in, insulin itself, how that dictates where fat is going. We could probably tie this into metabolic rate and calorie burning, and the idea that is very much promoted in my industry in particular, that you need to maintain caloric, control, and to lose weight, to gain weight, whatever, you need to lose weight in particular. You need to eat less and you need to move more, is the thing that everybody's told. Is this a good part of the conversation to pull that in?
Oh, yeah, for sure. Yeah, I mean, particularly in light of the definition we just gave about fat mass and its relevance. Specifically, it's the size of the fat cell that matters most. And so thus, if it's the size that matters most, it's the size that we should focus on. So how can you shrink fat cells? And that becomes relevant for both hypertrophy and hyperplasia. If there are people who have hyperplastic fat growth and have a much easier time getting fat, it still is a matter of shrinking the fat cells. It is not a matter of losing the fat cells. And that's an important distinction. The fat cells are very, very long-lived. They're not immortal, but they're very long-lived. And so if someone's losing weight, it's not because their fat cells are going away. It's just that they're shrinking them so considerably. So that is the matter at hand. How do we shrink fat cells? And there are two steps a person can take. And I like to use this analogy where we think of it like a journey, and that it is a fat cell shrinking journey. And we are at the beginning of this journey. We who want to shrink our fat cells, we have 2 feet. We have 2 steps we can take. One step is going to be an energy step or a low calorie. And the other step is going to be a low insulin step, because those are the 2 variables that influence the growth of fat cells. You must have a stimulus telling the fat cell to grow, which is insulin, and you must have sufficient energy to fuel that growth, which is calories. You cannot have fat cell growth in one without the other. It is incompatible. It doesn't work. But just to really put a fine point on that, as you noted, within the realm of understanding obesity and why we get fat, we have unfortunately created a culture, you and I are fighting it, Casey and I specifically, where it is purely focused on calories. It has become purely a matter of thermodynamics, which is ridiculous. Case in point, I have fat cells that are growing in my lab across the hallway right here in this building. Fat cells growing in a little petri dish in an incubator. We have within this little petri dish, the cells are growing in a soupy little broth that we call a culture medium. And within that medium are all kinds of calories. There's glucose and fats that these fat cells could take up and use, but they don't. They stay skinny little small fat cells, even though they are swimming in a little sea of calories. They don't take them up because there's no insulin in the culture. The moment we spike in insulin, we can check it 12 hours later and they're big and fat and juicy. Now they know what to do with the energy that they have. This is perhaps no more evident than in a type 1 diabetic. A type 1 diabetic can totally control how much insulin is in their bodies. If they decided to go and eat an entire chocolate cake, They would not gain a single scrap of fat on their body if they simply underdosed or didn't inject their insulin entirely. And indeed, that is so tempting to some type 1 diabetics that they do it. They take advantage of this fact and deliberately underdose their insulin, creating a problem called diabulimia, which is basically an eating disorder that is driven by the person simply failing to inject sufficient insulin. They are eating thousands of calories a day, and they are as skinny as they want. I mean, imagine the temptation, everyone listening. All they got to do is not poke themselves with a needle, and then they can be as skinny as they want. So don't ever think that fat cell growth is a matter of energy alone. Now, energy matters. You cannot stimulate, you cannot signal a fat cell to grow in the absence of energy to fuel that growth. So insulin's telling the fat cell to get big. The calories are giving the building blocks for it to actually build itself bigger. Now, those are the two variables that promote the growth of fat. Those are thus the two variables that we leverage to shrink the fat cells. Now, back to this analogy of the journey. We're on a fat cell shrinking journey. Most people start with the first step being low calorie. They just jump right in. They're cutting calories, which means inevitably, invariably, they're cutting fat, because fat has more calories, and that means they end up eating more carbohydrate. Well, carbohydrate stimulates insulin. And we know from well-controlled studies that if you give people two different types of meals, but they're exactly matched in calories, they are isocaloric. If the meal spikes insulin because it's higher carb but lower fat, they will be hungrier much sooner. And this is what we see here. This is the reason why so many people are so doomed to fail. If they start their weight loss journey with low energy being the first step, but they haven't addressed their high insulin, the total amount of energy in the blood goes down because insulin's pushing it into the cells of the body, because insulin wants to store the energy. And this becomes a problem for the brain, who can't store energy. The brain needs to be getting energy from the blood constantly. And if there's not enough energy coming into the blood from the diet, and there's a lot of energy going out because of the high insulin, which hasn't really been addressed yet, it's no surprise that the person gets hungry, and hunger always wins. This is why, Casey, we will never see a reunion tour of the game show, the TV show, The Biggest Loser. You will never see these people again because they gain it all back and then some. They go back, they materially surpass where they started, because the whole time under these rigid, strict conditions where they are being starved and exercised, not to death, but I'm sure it feels like it to them, they will lose substantial weight. But they've not really addressed the insulin. The brain is starving, it is hungry. Hunger always wins. So if the first step is a low energy step, hunger will win, and they'll find themselves right back at that beginning line before they know it. So let's take the other step first, which is the low insulin step, because it need not be based on low energy promoting hunger. You can tell the person, eat when you're hungry. If you're not hungry, rather, don't eat. So let hunger dictate when you're eating or not. But when you do eat, follow three basic rules, and you alluded to them at the beginning of our discussion. Control carbohydrates, which is don't get your carbs from bags and boxes with barcodes. Have whole fruits and vegetables, don't drink them. That's basically the gist of the control carbs angle. 2, prioritize protein, focus on high quality animal sourced protein especially. And then 3, don't fear the fat that comes with that protein. There is no protein that exists in nature without being coupled to fat. It does not exist. In our fear of fat, and perhaps in our hubris, we have split them apart, but we've not done ourselves any favors. We do not absorb and digest, or the other way around. We do not digest and absorb protein as well if we get it alone. We want to get protein with fat. That is how it comes in nature. That's how we've been designed to eat it. So the third and final point, again, being don't fear fat. So those rules, control carbs, prioritize protein, don't fear fat, will help someone address the low insulin step, because it's carbs that spike insulin the most, with protein and fat having little or no effect. So in that case, by lowering insulin, they are starting to mobilize their own energy. They're increasing their metabolic rate. They're making ketones, which are wasted calories that come out of the body. So they're really just wasting energy if insulin's low, because if insulin's low, the body cannot hold on to it. And then they will lose weight. they will take several steps or hopping on that 1 foot of low insulin down the path to the insulin, to the smaller fat cells. And then they may get to the point where they say, but I want to go a little further. Now you can take the low calorie step or the lower energy step, but not because you are counting calories or you are avoiding fat. You do it because you have frequent fasting. You have structured fasts that you've worked in. When it's time to eat, you eat, but you still follow those same 3 rules that you followed before. But now you have structured fasts, and that will lend itself to beginning to restrict energy in a bit more of a natural state without feeling like you're depriving yourself. But as I invoke fasting as that kind of last principle, the fourth and final part of this, let me just say how you end your fast matters more than how long you fast. When we think about fasting, we think about the window, the timeline. I'm doing a 24-hour fast, and we don't really necessarily plan for how it's going to end. How you end matters more than how long you've done it. So plan carefully, have a set meal ready to go. Don't do everything you can to avoid binging and then setting yourself up on the cycle of overeating, feeling miserable, feeling ashamed, resolving to do better the next day, and you do it again and again and again.